Muted.
Good morning, everyone, and welcome to today's webinar, Learning How to Act on Your Big Data in Real Time. I am Megan Souza, Marketing Manager here with Done Solutions Group. Before we get started, I would like to go over a few items. This webinar will be recorded, and we've got recordings of all previous webinars on our website in the event that you missed any in the past at donesolutions.com. We will be taking questions at the end of the presentation, and for those questions that are complex or take a little more time to explain, we do promise to follow up with you for those. So let's take a look at today's agenda. I will begin by doing introductions to Done Solutions Group. From there, I will turn it over to today's first presenter, Sunil Parekh. Sunil will begin by discussing big data and real-time analytics in Microsoft Azure and HDInsight. From there, you will turn it over to our second presenter, Janani Eshwaran, and she will go over a demo for telecom real-time scenario. From there, we will cover what's next, after which we will take your questions. So let's begin. Done Solutions has a long history of delivering innovative business technology solutions. We are headquartered just outside of Chicago and have offices in Minneapolis, Raleigh, and Bangalore, India. Our offerings fall into two practice areas. Our application development solutions feature portals, e-commerce, and content-managed websites, mobile application development, and custom application development. Our analytics solutions feature analytics and BI platforms, as well as data warehouses and data integration. We are authorized SAP, Liferay, and Microsoft training providers and offer classroom, virtual, private, and custom options. We believe training is important because once we deliver a solution, we want to make sure that those who need it know how to use it and maintain it. Our clients, some of which are listed here, are a combination of Fortune 500, mid-market companies, government agencies, and nonprofits across all verticals. About 80% of our business are commercial clients, and 20% are nonprofit and government. We maintain strong partnerships with top technology companies in order to offer our clients the most innovative solutions available today. Our analytics practice helps deliver information to decision makers throughout your organization so that it runs better. We can help with decision making by not only looking into the rearview mirror, but also looking forward into the future by leveraging predictive analytics and data mining techniques. Thank you for allowing me to introduce you to Done Solutions. I will now turn over the presentation to Sunil. Welcome, Sunil. Sunil? Just one moment. It seems we've got some technical difficulties.
Oh, sorry for the technical glitch. Okay, so let me go back to my first screen. So hi everyone, and welcome to webinar on how to act on your big data in real time. I'm Sunil Kumar Parekh, analytics consultant at Done Solutions, and I will walk you through the big data and the real-time analytics concepts, and then Janani will demonstrate a use case for the telecom industry. So let's get started. So why we are here? Of course, to learn how to act on a big data in real time. So what we have done here, that we have divided this topic into two webinars. In this webinar, we are going to learn about big data and real-time analytics concept, and we will see how we can store and analyze streaming data. And in the next webinar, we will demonstrate how to process streaming data in real time for faster decisions. Before we go to the concept first, there should be a first question in your mind that why we need to do this. Great question. So let's understand what are the people in the what are the companies in the industry are doing that. So Twitter needs to crunch their billions of tweets to just publish what is a trending topic. So when they want to publish, okay, what are the trending topics? There are millions of tweets which are generating, and then they are showing it in the real time. That's one use case where the data is generating in a large volume, and they have to show it the real time is what is exactly trending now. Another example is the credit card companies, which needs to crunch billions of transactions and identify a fraudulent record. Like you take example, if you are going to another city and you perform any transaction in another city, you will get a message whether it's you who performed this transaction or if it's not you, then they can identify that. So that requires a lot of processing, and then so many transactions happening all over the world for that particular credit card company, and they have to process this through the millions of records and then identify whether something is going correct or something is going wrong. Another example is of the mobile applications, which is generating a lot of data, and we can take an example of WhatsApp. So you know WhatsApp, there are worldwide users of WhatsApp, and they are generating, sending a lot of messages, texts, videos, and so many things. So WhatsApp needs to make their service available and the performant, and also need to do it in a very real time. So there are many use cases like this presented in the real world, which requires a real-time processing or real-time analytics on that. Some of the cases, like maybe you can consider of devices on a truck or your car device or your home security system, which a company which is handling that home security system, and then all the homes are connected to the servers, or maybe a mobile company which have a multiple towers and then generating and sending that data to their data centers. So to handle this data, the current system cannot handle it, or and it can definitely handle, but there is some limitation to it, right? So let's understand what's that limitation may be. So it's a big data, right? Because big data is too large for the traditional or relation system to process and store it into your data center or maybe whatever the servers you have. It's not able to, even though it may able to process, but it may not able to perform or may not able to scale at that level where they can process and analyze this big data, and that is also in real time. So let's understand the first famous 3 V's when you can say, oh, my data is real big data. So yes, these are the 3 V's called volume, variety, and velocity, which 3 parameters are the major 3 parameters define that whether your data is big or not. So let's understand one by one what it has. So first is volume. Volume, it talks about the data which can be in form of records or transactions or your files, and that's in a terabyte of. The volume is in terabytes, and which need to be processed and then get the analytics out of it. The second V is, let's talk about the variety first before we move to velocity. It's about what type of data it is. It may be a structure which is in the databases, which be unstructured, which is in some format which is known but still, that may be a semi-structure on the unstructured where the format is not known. We have to process, understand that data, and then perform some analytics on that. And the third one, which is the central topic for today's discussion is also a velocity, that okay, you have a large number of volume of data, you have a variety of data. Now the third challenge is which needs to be processed within certain time. So that velocity, which is defined by the business or the requirements, that oh, this data needs to be processed okay in the batch, or maybe in near time, maybe the hourly, 4-hourly basis. But in some cases, which we discussed, it's required in real time. So let's understand more on this velocity term. So why the velocity is more important in the 3 V's of the big data in terms of real time analytics. So velocity is, in terms of data, velocity is the speed at which we can collect that data and process it and get the insight from it. So, and whatever the window or whatever time we would like to define it, that defines what velocity you need. So previously, okay, even though the volume is large, and if you would like to do it with the traditional, it takes hours and hours and hours, where big data solutions came like Hadoop, and which shows, okay, now we can do it, but we will do it in a batch, or maybe some will do it in the near time. But the primary drivers, just we discussed in the previous slides, like a social media or the IoT stuff, which is the Internet of Things, where all your devices are connected to internet and then generating lots of data, and which they are sending to your data center or to the cloud, and all the mobile applications which are also generating that kind of data. But whatever the speed they are generating the data, the challenge is, okay, as soon as that gets generated and then sent to the system, we need to process that immediately, maybe with the single record or the window of the record, and then need to send it to the analytical system or to the different system as an output or at some decision making measures to that. Just take an example of a mobile of an IoT system, just like a truck. You have a truck. There are many devices which are fit on the truck, maybe in the engine, with the refrigerator installed on the truck, or with the GPS data which that truck is generating. So all this data, it's while the truck is moving, it gets generated and it's sent over across the data center. Now the challenge over here is, if there is something wrong, that if the temperature of the refrigerator went below or went up at a certain point, or the fuel is going to empty, but the next fuel station is not near, all the scenario which has to be handled in the real time. Oh, as soon as we know, oh, it's going down quickly, and then you have just next to petrol pump, just fill it, something like that, then definitely we need to know that in the real time and then process it, so that the driver or the whoever the operator can take action on that side. So there are many more and more such kind of scenarios which are becoming real time. You may also have some scenarios where you are processing that data, but now you want it in a real time. So let's understand, okay, how we can do this in a real time, and then how we can process this big data in the real time. So this is how the real time analytics happens. So as we discussed, there are big data streams which are coming from your network device log or clickstream application, or the credit card transactions, or the mobile data, which are different streams, which is coming with the great velocity also, which needs which are listened by the listeners in such system where we are doing a real-time analytics. And these listeners will receive these streams at whatever speed it came with, which is in real time, and it's also it stores in their whatever storage, in maybe in memory or whatever the listener gets stored that data, and it's so scalable and fault tolerant that it can able to listen to all those streams and then store it over here. And it can, so the main idea of the listener over here is to get all the stream data and don't miss any single step, because any single record also may be important to take a decision for that. So, but the speed is important where this is happening in the very real time. So there are many technologies which is coming in the market which are able to help to listen all this data, and this data can be listened and then also store in the such a way that it's scalable and the fault tolerant approach of that. So once we got the data is listened by the listener, the next approach is of the processing it. So that processing may be complex, that okay, based on the data or number of records, you have to apply algorithm 1, 2, 3, 4, and then also find some values and then see the threshold and something like that, and then take a decision. Oh, if this is fitting in that particular threshold, then do this or do that, or send a notification or just store or whatever. So that kind of complex processing is required on the stream data. So that job is done by there. As soon as the data comes, we can process that in that particular time window, and then we can either, the next step is to store it into a target system. So that can be directly stored into your application databases, or can be shown events and your applications or the analytical engines, or sometimes you can just store all this data in Hadoop as it is, and then so whatever the real-time processing is required, just do it. But the data, since we are capturing all the data, the remaining data, just store it in Hadoop and then do the next processing, which doesn't require the next real-time kind of window. So that's how this real-time analytics processing works, where it starts from getting the data into streams and end up with the storing the data for the future analytics. So what are the technologies? There are many technologies available in the market which does that, but let's talk about more on the Microsoft Azure HDInsight, which we are going to use in our demonstration. And let's first understand its feature, what it is, and then what it provides to do a real-time analytics. So Microsoft Azure HDInsight is is based on the Hadoop platform, which is they are using the HawthorneWorks data platform to deploy the Hadoop clusters into Microsoft Azure platform, which is a cloud platform by the Microsoft. All the data, it gets stored in the Azure Blob Storage instead of, so in the Hadoop system, it gets stored on the disk. In the Azure Microsoft Azure HDInsight, it gets stored in the Azure Blob Storage, and it has a capability to scale up to the petabytes on demand. So you can just play with the cluster size, that you can increase and decrease that cluster size on demand, and it has a capability to spin up the Apache Hadoop as well as Spark and the R clusters in the cloud. Let's see the ecosystems of the Azure HDInsight. So it has all the supporting tools available in the Hadoop distribution, which like it can process a data in a batch using MapReduce. It has a PEG for ETL, Hive, HBase, Strom, and for and also the Spark, which we are going to use for our demonstration, which is in-memory real-time stream processing engine. Azure HDInsight also provides a capability to connect to a Power BI, which is a visualization tool available in Microsoft Azure, as well as you can also connect it with the Tableau, Mira, or QuickView, all the other visualization tools which can be deployed in a VM of Azure Cloud. And it also provides a capability to use the Jupyter and the Apache Zipling tools, which requires to sometimes requires to use for the Spark streaming. So saying that, let's understand more on the Spark streaming, which is used for the real-time analytics. So Spark Streaming is an extension of the Spark API that enables scalable and high throughput fault-tolerant stream processing of live data streams. So all this definition is what we just seen before in our real-time analytics diagram, that okay, if you would like a real-time processing, we need a listener, which plays a role of by the Spark Streaming, and then the next part is engine, which actually process that stream. So which we are going to use the Spark engine to process that stream in our demonstration. So Spark Stream takes the input of data as a stream, and then it's divided into the number of batches, and then that batches get processed by the Spark engine, and it provides the desired output for the applications or your data storage. So now you know how the real-time analytics works, and now maybe you are more interested how it works in Azure HDInsight. So I'm giving it to Janani. So over to Janani.
Thanks, Sunil. Hi, everyone. Good morning, good afternoon, good evening, wherever you are. I'm Janani Ishwaran from Down Solutions Group, working as an analytics consultant in big data area at the Skokie office, Illinois. Moving on to our demo, as Sunil mentioned, our demo will focus on the use cases in telecom industry, which is telecommunication industry, or some say it as communication service providers. So everybody agree that data is definitely becoming a very important asset in any industry given today. So that is because with the rapid increase of mobile usage, mobile internet usage, and internet usage, there is a lot of data lying over there for any industry to do some analysis and get some insights and benefit from that. So in coming to telecom industry, they have large amount of access to data sources like customer profiles, telecom usage patterns, network data, device data, and the location data, and there are so much data for them to get some insights and get benefited out of that. So how are they getting benefited? So some of the use cases like targeting their customers by marketing good products and also offering them some personalization only for their account. So how are they going to do that? That's by analyzing the usage pattern. They can like how they're using our data plans. Are they going to use our SMS plans a lot, or are they doing more number of calls than SMS and data usage? So based on their usage pattern, we can offer personalization only for their account. So that can be one of the use cases, and you can target the customers based on the usage pattern also. And the next is you can do some customer journey analysis based on the feedbacks given by our customers, because these days for any business, reviews and ratings are the major data for any business to focus on where they are affected and how they're performing among the customers, right? So based on the reviews given by the customers, we do some analysis and find out where we are affected and improve on our affected areas. So that can be one. And then most important and tricky and tough decisions to be made in any industry is planning on their infrastructure and doing some investments on their infrastructure. So if infrastructure is not good, of course, the services are interrupted and customers are unhappy. If customers are unhappy, we are not doing a good job. So by analyzing in telecom industry, by analyzing the traffic data to a tower, we can plan some investments in that particular area and then give up uninterrupted services. So when customers are happy, yes, we are doing a good job. So you can do that using big data tools. And next, the most important thing is proactive measures. These days, any telecom industry or any industry, they use big data tools to build some analytic tools to proactively identify the issues even before they are occurring, and then providing the solutions so that services again not interrupted, and again the customers are happy. And so there are not only this, there are many more use cases in telecom industry. So today we'll target on the first three, targeting the customers, customer journey analysis, and how they are doing the infrastructure planning and how they're investing on it. So let's go on with our demo. So moving before to the demo, let's see what are the scenarios we will be doing today, or if you wanted to do, if you're facing, if you want to capture data in real time, and also after capturing it, if you want to store it in some large data lake like Hadoop, in a distributed fashion, so that when doing some processing, you can do the processing in a distributed fashion to get a faster processing speed, and also to perform analysis on the stream data and visualize the information interactively. So if you want to do all these things, yes, come on, let's go to the demo. And before going, let me introduce you to the tools which I'll be using today. I'll be using Azure HDInsight cluster and Spark streaming, Azure Event Hub for collecting the events, Power BI for visualizing the data, and Azure SQL database, which is also in cloud, to have some customer details, location details, and tower details. So these are the tools which I'll be using for today's demo. This will be our demo architecture. So first one, we'll be streaming the data into Azure Event Hub, and this is captured by Spark streaming, which is also inside our HDInsight cluster. The stream data will be in terms of bytes. So in order to convert it back on the fly to a semi-structured data, or to some extent of structured data, we use Spark streaming to capture it and transform it on fly, and then move this transformed data to HDFS files system for storage purpose. And then since whatever stream data are in semi-structured format, it is not good for analytics purpose. So again, we have to turn them back into some structured format to do some analysis on that, right? So that's why we use Hive here, and we move some of the real-time data to SQL database using Scoop. So we will be scooping few of the real-time data to our SQL database. And so now we have all the data ready to be analyzed and visualized interactively to gain some insight. So that's how we have Power BI into our picture. We'll get the real-time data from Hive, and some data like customer details, location, and tower details from SQL database pulled together to Power BI, and we'll get a beautiful insight. That is our demo today. So the first step, as I mentioned, let's go and collect the events in real time and pass it to Azure Event Hub. So I'm going to start my events. So now the events are being generated, and can you see the speed? It will be even more speed. I've just given some delay so that you can see the data. So it will be faster enough. So now it's moving on to Azure Event Hub, and our next step will be consuming this real-time data into our Hadoop cluster. So for that, we use Spark streaming. In order to receive the streams, I have written a program to receive the events in Spark. So this is now preparing your Spark cluster to receive the events. It's just checking the checkpoints where I have left last to consume the event. So now it started consuming it. And our next step will be, as and when the data are getting consumed, it is, as I said, it is getting stored in HDFS file system. In our case, the storage area will be Azure Blob Storage. So if I'll show you where storage, how the data looks. Let's go and check. This is my container here in Azure Blob Storage. So if I go here, I have streamed all my data to data folder. Inside that, CDR events. So these are my data in real time, which has been getting streamed now. It will be in semi-structured format. Let me show you. It's in JSON format, which is semi-structured. So you want it to be even more structured way to do some analytics, right? So on to our next step. So we'll create a table in Hive and then process this events and analyze this events, which is generated in real time. So I'll show you this Hive table. So I have created a telcost table which will process this JSON formatted data into a structured fashion so that you can analyze it and get some insights. So this is my table structure. I'm consuming tower ID, the frequency it has been used, the bandwidth it has been consumed, and customer who has called to whom and which type of call, whether it is a data or SMS or it is a call, and call result, whether it has been answered or dropped or busy or call quality, and the call protocol it has been used, and the data speed, if at all if they are using the data, and also the data usage, how much they have consumed, and also weather, currently what weather they are facing, and some day ratings given by the customer if at all they have given us the rating. And now let me go and show you some data now in a structured fashion, which is good for analytics side now. Yeah, now it has been processed into some structured data, so wherein you can perform some analysis. Moving on to our next step is if you want to move some of the data, real-time data to SQL database or to any database, you can scoop it using scoop tool. So let's go and check out how you can do that. So I'm in the scoop installation directory in HDInsight. So I'm executing a scoop command. Before executing the scoop command, I'll show you where I'm exactly scooping this data. I have created a table in my Azure SQL database, which is nothing but customer charges, which will just have customer ID and the total charges so far by the customer. Let me first show you whether is there any data. So there is no data, right? So let's pull this sum of the data from the real time and to this table to using scoop. So this job is in turn converted back into MapReduce program. So it just takes some few seconds to export all your data, real-time data to database. We are just extracting few of our data to database for good analytics. Just take some time because it has submitted its job. Now that MapReduce job is getting executed. Yeah, we are done. It just takes a few seconds to do that. So now let's go and see whether data has been exported here. Yes, we have exported, and we can use it for our analysis. So now we have a data. So in my database, I have some customer details, tower details, and the location details. So, and also this customer charges table now, total charges for every customer. So let's go and do some analysis on this. Our next step will be on Power BI, where we can visualize this real-time data as well as the data which is there in our SQL database to get some beautiful insights. So that will be our final step in this demo. So this is my structure now. Telco table is a real-time data which is from Hive, and tower table and the customer table are from SQL database, and customer charges as well is from the customer database. Sorry, SQL database. So this is my now. So let's, as a proof, this is our data we have pulled it from Hive, from the real-time storage. And now let's do some analysis and beautiful insights. As I mentioned, let's go and see how we can target customers. This is like this here is this shows who are the customers based on total charges. So see, some as now from this real-time data, we have $64. It's now the high top customer that charge now among others. So see, let's go and check how we can offer him some products and target him. So working on this something customer, we can see that he sent quite a bit of SMS and then so much of data, but he has more number of calls. So we can customer see by giving him good in call plans. Then we focus him for data use for SMS plans. So now, if you want to go and check how C2 customer giving us a revenue using data plans a lot, and he's making only few number of calls so far, and so we can data target him for the data plans. So that's how you target customers and personalization his own account. And to the next case, will be reviewed customer journey dashboard. We see here how our users are rated. We have got rate so far, so good, but let's go analyze. We have got very good rates. So we click on this. We said, okay, our answer, but so calls which have been answered and given rating have dropped. That's why we got very bad rating. And then that is, but we also consider real-time data. Why they have given that is, it's because it's rainy and thunderstorm, so that's why it's being interrupted, and that's why it's got a bad rating. So you see how it was affecting. Next is cluster planning. You see, Texas, California, and more people are using our services. But we think that looking at this graph, not people are doing, not giving us a value, but go analyze. So by this chart will give you the revenue to highest revenue people. So we see Tower 7 has given us good revenue. People who have used particular area has given us a good revenue. So by looking on that, we see the customers are from Illinois. They are from Skokie, Illinois, and they are giving us good revenue. Doesn't mean my people giving us a good, just looking at how more of it's to that particular from that particular state. So that's how you do some structure planning and investment, and if more number of on that particular problem, yes, you have to definitely concentrate on those areas and do some investment so that service is not interrupted. So on to our demo. That's it. Thanks for this opportunity. Handing over to
Thank you, Janani. That's a wonderful demo on that. So let's quickly recap before we go to the what next. Let's quickly recap what we have seen in that demonstration. So we can divide that demonstration in 4 parts. First is the capturing that streaming data, which is coming from different sources. So in this case, it was a call records coming from the mobile towers, which has been captured by Azure Event Hub, which is like a message queue system, which can handle n number of millions of calls, which can scale up to handle the millions of calls over there, which is our listener in the previous diagram. From the listener, our Spark streaming is consuming that those events as it comes into the listener or the event Azure Event Hub, and it started storing that into its temporary storage. Next step is what Janani showed is about how to store that data into Hadoop. So from the Spark streaming, we have a job which is running the real-time data and which is storing that data into the HDFS. And from that, we created some Hive tables on top of that data where we can see the data or just create a schema on top of data, which can be available for other tools to perform a query on the HDFS data. The next step after that is, which is third step, is move that to the database. So we use Scoop and scoop that data into the SQL warehouse. And once the data is available in the warehouse, in the final part of the demonstration, we've seen how we can visually analyze that data, whether it can be, we can analyze it directly through the data which is there in the HDFS, which may be at the raw level, or we can put that data into either to database or your enterprise data warehouse, and then other data which is there, we can join that data with that and then also perform analytics on top of that, and then we can visually see that over there. So that's from the our current first demonstration. There is more. So in today's webinar, we have just seen how we can capture that streaming data in real time and store that into the Hadoop and then use it for the later analysis. But in our next webinar, we are going to see while the data is coming as a stream, we will process it over there, and also we will visualize that in real time, so we can see the real time dashboards, which is updating real time. So hope you have learned how to act on your big data in real time, and you may now excited to do it with your data. So if you have any project on big data or real time or big data with real time, please let us know. We are ready to help you out on that. Also, if you have wondering how it can be benefit to your organization to process your data, and then what output can become from the data, and how we can do that, we are ready to help you on the proof of concept, and we'll explain you what are the benefits you can get by doing it. We are processing your data in real time. So please contact us at info@reddunsolutions.com. Thank you everyone for attending this webinar. Megan, please let us know if you have any questions.
Thank you, Sunil. You and Janani did a great job. We don't currently have any questions right now. If anyone does have a question, please feel free to type that in. We'll remain on the line for a few more minutes to cover any of those for y'all. If not, thank you for joining us today, and hope to see you at our future webinars, and make sure that those invites go out to you as well. Enjoy the rest of your day.
Thank you.
All right, as it looks like we're not getting any questions, I'm going to go ahead and sign off here. Again, if you do have any in the future, please email either of the emails on the screen, or you can email info@dunsolutions.com. We hope to see you again in the future. Thanks for joining us.